Let's talk some more about statistics using the measures of central tendency and spread. So, first, a little bit of vocabulary. The mean is often called the average, and it's the most common measure that we use for your central tendency. It is the sum of all your data divided by the number of data values. So, if I have five numbers, I add up those five numbers and then I divide by five to get my mean or to get my average. Our next piece of vocabulary is the mode. This is another measure of central tendency. The mode is the value that occurs most often in the set of data. So if you have a list of 10 numbers and three of those numbers are the number seven, then seven would be your mode in this example. Let's go ahead and write down that definition. Pause if you need to write down that definition for mode. Now let's look at the median. This is the middle of the data set arranged in numerical order. I'll explain and then we will write down these steps. So basically the median is dead middle. And to calculate the median, this should say median, not mode, we want to put the values in order from least to greatest or from smallest to largest. And if there's an odd number of data points, use the value in the middle. That's the median. And if there's an even number of data points, we're going to use the two middle values. We're going to take the average of those two middle values. So let's go ahead and write that information down, the definition and the steps to calculate the median. So pause for a moment so you can get that information. And then let's look at our first example of how to use this information. We'll be using the Desmos graphing calculator, which you can have on an app on your phone or on your computer. So for our first example, it's asking us to find the median, and mode. In Desmos, what I want to do is create a list. These are all dollars, but there aren't dollar signs on everything. I don't need the dollar signs. I just need a list of these numbers in Desmos. So in Desmos, I'm going to type a list. In this case, I named that list of numbers L1. So I typed in L and then 1, and Desmos wrote it this way. Equals, and you want to type a little square bracket like this, and then type each number separated by a comma. So that's going to be my list. Now, my questions are asking me for some basic information like the mean, median, and mode. So let's go ahead and use Desmos to bring that information up. First off, to bring up the mean, I can type in Desmos mean, and then in parentheses, L1, and it will tell me the mean. My mean is 483.8. Or if we round to the nearest whole number, we'll say our mean is about 484. The next question asks me, what is the median of this set of information? So in Desmos, I'm going to go to another line and I can just get the general statistics from using the command stats and then in parentheses L1 because that's my list. So I'm looking for the median and there it is right there. The median is 400. Okay, that's not terribly hard to understand. That's the number in the middle. And then my mode. My mode is the number that occurs the most. If we look at this, there are 13 values, and I see the number 300. 1, 2, 3, 4, 5, 6 times. And then there are seven other numbers. I mean, 400 is only repeated twice. But so our mode would be 300. So we can use our calculators, either the TI-84 or Desmos, to find this information. Now, if we're going to find a missing piece of data, I want you to pause for a moment to get down these steps. To determine the missing piece of data, I'm going to set up the average formula based off of the information I have, and then I'm going to substitute the average and all the known information into that formula. And for your missing piece of information, add X. After that, I'm going to simplify. So I'm going to add up all of my like terms, and then I'm going to use my normal steps to solve for x. Go ahead and pause and make sure you have these steps down in your notes. Okay, if you have these steps down in your notes, let's look at an example of finding a missing value. So we have a baseball team scored the following number of runs in its game during the current season: 6, 2, 5, 9, 11, 4, 5, 8, 6, 7, 5. Okay, there's one more game in the season. If the team wants to end the season with an average of at least 8 runs per game, sorry, at least 7 runs per game, what is the least number of runs the team must score in the final game of the season? So how many runs do they need to score so that their average per game is 7 runs? So what I'm going to do is add up 6 plus 2 plus 5 plus 9 plus 11 and add up all of those numbers that they gave me, because I'm setting up my average formula, or my formula for the mean. And then I'm missing a score. I want to find out what's the last score. So I'm going to say plus x. And I'm going to divide that by the number of values. So they've played 11 games, and we want to know what they need to score in the 12th grade game. So we're going to divide everything by 12. And that should equal an average of 7. Now, to get 7 by itself, let me go ahead and combine my like terms, add up all these numbers before the x, and I get 68. We'll say 68 plus x over 12 equals 7. And now let's solve for x. So I want to multiply by 12 so that I can cancel out. And I will get 68 plus x equals 84. And to get x by itself, I subtract 68 on both sides, and x equals 16. So to have an average of 7 runs per game, we need to score 16 runs in this most recent game. Now, let's look at another example. Keith knew that he has an average of 90% in his Spanish class, but he lost one of his papers. The 3 papers he could find had scores of 96%, 88%, and 90%. What was the score on his 4th paper? So what is he missing? He knows he has an average of 90%. So I'm going to do this thing again where I add up 96 plus 88 plus 90. And I don't know what the 4th score is. I'm going to add plus x. And that's over a total of 4 papers that have been graded. All of this should equal out to 90. So, like I did last time, I want to go ahead and combine my like terms. So I'm adding up 96, 88, and 90. I will get 274 plus x. And all of that's going to be divided by 4 and should equal 90. Now to get x by itself, let me multiply by what's on the bottom, multiply both sides of the problem by 4, so that I get 274 plus x equals 360. And to find x, my last step, I want to subtract 274 from both sides of the problem. So 360 minus 274, x equals 86. Let's try one more example here. Mara wants to finish the semester with at least a 90% for her biology class. The 3/4 grades have been 92%, 84%, and 90%. What must she achieve in her 4th quarter to meet her goal? So we're going to average together her quarter scores. We'll start with 92 plus 84 plus 90. We want to know what she scored, what she needs for the 4th quarter. We'll put plus x for that. And to average these all together, you add them and then divide by 4. When you add them and divide by 4, you should get 90. And that would give her this average. So once again, let me add these numbers that are like terms: 92 plus 84 plus 90. And remember, X is not a like term, so I'm not going to combine that there. I will get 266 plus X. All of that is over 4, and that equals 90. So the next thing I want to do is multiply both sides of the problem by 4 so that I can work on getting X by itself. The 4's cancel out over here. And I'm going to get 266 plus X equals 90 times 4 is 360. Okay, and to get X by itself, my last step is I want to subtract 266 from both sides of the problem. These get rid of each other. I bring down my X, bring down the equal sign, and 360 minus 266 gives us 94. So Mara must earn at least a 94 to have a 90% average for that class. So let's move forward to measures of spread. First off, the range is the difference between your maximum value and your minimum value. So to find the range, we substitute the max minus the min. Our interquartile range is a special piece of information. It's telling us the third Q3 minus Q1, basically. So it represents the middle 50% of data. Let's write it down. So make sure you pause to write it down. To find our Q3, we subtract Q3 minus Q1. Next, we have outliers. That's basically a piece of information that doesn't belong. It's way above or way below the majority of the pieces in the data set. And standard deviation tells us the average distance each data point is from the mean or the average. Let's go ahead and write those definitions down. All right, so outliers tell us which pieces of information fall way outside the normal guidelines for our data set. Standard deviation gives us the average distance each data point is from the mean. And to put them together, outliers make our mean bigger. And outliers make our standard deviation bigger. They can also make our mean bigger or smaller, but the standard deviation grows or shrinks with the outliers. So we're going to take the next bit of information and put it into our calculator to find the IQR, the interquartile range. And that's going to be list L2 on my calculator here. I have that information. Now I'm going to use that information to find out some outliers. So the IQR, or the interquartile range, is Q3 minus Q1. So that's going to be 61 minus 11, and that's 50. The IQR, or interquartile range, is 50. Now, to find outliers, we're going to use a 1.5 IQR rule. So 1.5 IQR rule. Once we find the upper and lower limits, well, we're going to find the upper and lower limits using the 1.5 times the IQR. So 1.5 times 50 is giving us 75. So to find the lower limit, I'm going to take Q1 minus 75 because that's 1.5 times the IQR. And to find my upper limit, I'm going to find Q3 plus 75. Basically, any numbers that are smaller than the lower limit and any numbers that are bigger than the upper limit are going to be considered outliers. So Q1 minus 1.5, basically that's 11 minus 75. 11 minus 75 is a negative 64, so that's my lower limit. My upper limit, we want to use Q3 plus 75. My Q3 is 61, so I'm going to add 61 plus 75, and I get 136. And in my data set, I'm looking for any numbers that are lower than -64. I do not have any numbers lower than that. And then any numbers that are above 136. And do I have any numbers that are above 136? Yes. So 220 is above 136. 220 is our outlier. So 220 is an outlier in this set. And that's the same information that we have there already. Now, example 3, we're going to find the standard deviation. I want to put this information into my calculator again in the form of a list. I have it in my calculator as L3. And to find the standard deviation, it's pretty simple. In my calculator, I'll type STDEV and then in parentheses the name of the list, in this case L3, and boom, 2.345 or about 2.3. So the standard deviation is about 2.3.